Good afternoon, everyone. Welcome to the intro to our workshop. We have our in-person part, and also there are some attendees attend this workshop online. So let's get started. Let me double check this. Okay, it's recording. Okay, this workshop is part of UConn Sport and Analytics Symposium 2022, and this is this workshop aims to give a quick tour of R. So for any information you need, like for example, like the GitHub page and also the link to the GitHub page, you can find all on this on the event website. So if you go to the main webpage of the symposium and you go to workshop and you find the introduction to our workshop, and you can find this GitHub link. And if you click this, it will guide you to this page. So in this page, you can find the R code we're going to use and also the quiz we're going to do for this workshop. And also you can find the slides we use through this release link. So it's basically this HTML file. Okay. Then let's briefly introduce myself. My name is Fusheng Yang. I am a fourth-year PhD student in statistics at UConn, and I study in time series analysis and extreme value analysis. Currently, I am a research assistant at the Computational Climate Change Lab, and I work on projects about heat waves. So my future goal is to contribute to the broader field of environmental statistics. It's environmental statistics recently is a really hot topic. So for this workshop, you will need a laptop with R and RStudio installed. So you can find the links of downloading R and RStudio here. And for this workshop, you don't need any experience with R. So let me stop the video from now. Okay, so we're going to talk about our basics, our data structure, read and write data in R, data management, and we will have a brief overview of two packages, dplyr and ggplot2. So dplyr is for data manipulation, and ggplot2 is for data visualization. So R, what is R? R is a free and open source language and environment for statistical computing and graphics. So R is basically a computational language, and we have many ways to use R. One of them is RStudio. So RStudio is an IDE for R. For convenience, we will just use RStudio for our workshop. And for this, you need to install RStudio's desktop on your laptop. And let's take a look at the RStudio interface. So we have code editor, and on the top left corner, and environmental and history on the right corner, top right part. And then we have console. And also for our files, help packages, we can find on the right bottom. So for R, we can use it as a calculator. So we can do some basic calculation, such as addition, subtraction, multiplication, division, and exponentiation. So many of them. And there are also built-in functions such as square root, natural log, and something like and many others. And you can use the link here. And there are many other built-in functions as well as basic calculation. So let's take a look. So to do summation, we can just type in 3. For example, we want to do 3 plus 8. Then we just type in 3 plus 8, and then click Run here. And then for the result, we can find it here in the console. Then this is to do e to cube. So to hit, you also hit click Run, and you get the solution. And then for SQRT, this is square root of 15. So again, this is a built-in function, and we just click Run, and we have the solution here. Then we have some help function for you to find out some uses of some function. So for example, if you want to find what the function min is, then you can use there are two methods. One is to type in help parentheses, and inside you put the function min, or use question mark and then min. Then we can have it here, and we run the code. You can see the definition of min. You can see on the bottom right box. And then the same thing to use question mark. Just click Run, and we can get the same thing. And we have assignment operators. So the operator, so to use this arrow method, the operator always point to the value you want to assign. So we want to assign x to be 5. So the arrow point to x. And we want to assign y equals to hello world, and this point to y. And then we can also use equal. So we set z equals to 2022, and we can try that here. So we assign x equals to 5. And if we just type in x again, we can see x is 5 here. And then we assign y to be hello world, and run the code, and run y. We have hello world here. And we assign z equals to 2022, and we run the code, and we run z. We have the value of z here. Yes. The arrow is more for like for the equal sign is more mostly used in some local environment, and the arrow sign can be used for more global environment. So we have data types here. So in R, there are 6 basic data types. We have logical, so true or false, or numerical, so any real numbers with or without decimals. And integers, it's real values without decimal points, and complex values. And also characters, either single character or string, and also raw. For raw, we will not talk in this workshop. So let's take a look. For logical, we have this, we assign Boolean 1 to true. So we can see this, the value of this variable is true. And then we use the class function to check the data type of this value. So when we run this, we can see it tells us the class of this variable is logical. And then similarly, if we have a false, it's also logical. And then for numeric, we have, let's say we assign 63.5 to weight, then we run the code and weight. We check the class of weight. It tells us it's a numeric type. And then again, height. This is without decimal, but the class is also numeric. And then for integer, for a numeric value, you want to make it to be an integer, you need to put an L at the end of the number. So if we assign 180, we want 186 to be an integer in R, we need to put L after it. So we have class to be integer. So for complex is with any I contains in the number. So we have complex value, we assign it to be 3 plus 2i. And we have this, and then the class is complex. And then we have character. So for character, we have a single character, and we also have string. So for this, we check this A is a character. And then for the fruit, we assign it as apple, and this is also character. So for character, we can use either single mark or this double mark. Any questions on data type? Okay, then let's go to data structure. So R has many data structures. The most essential ones are vectors, list, data frame, matrix, and array. So the vector is a collection of elements. So elements in a vector must be for identical data types. So vector is always one-dimensional. And then list is a generic object consists of an ordinal collection of objects. So a list can have unequal dimensions or different data types. So we will show you. I will show you some example for this. And for a data frame is generic data objects of R, which are used to store the tabular data. So it's a two-dimensional format, and usually a data frame must have a column name, must have column names, and each column must have the identical number of items. And for matrix, it's rectangular arrangement of numbers in rows and columns. And matrices are two-dimensional. And they have to be with the same data type. And array is used to store the data in more than 2 dimensions. So arrays are n-dimensional data structures. So here's a table you can check. So for homogeneous means this data structure can only contain one single type of data. And for heterogeneous, it can contain different types of data. So let's see. So for vector, remember it's a homogeneous structure, so it can only contain single type of data. So we create a vector x. Oops, sorry. And then we have x here. It's a vector of numbers, and we want to check the second element. So we use x bracket and 2, that's the second element. So from this vector, we know the second vector is 3.5. So let's check that. Yes, this is 3.5. And then we want to add an element to the end of this original x. So we add 22.3 to the end of x. And then we can see here, these 5 numbers are the original elements in this vector, and 22.3 is the added one. And then we check type of x. And there are double means there are just numbers, just any real numbers. And then let's see, we want to assign y as a logic vector. So we have y here, and then we check the type of them. They are logical. Yes. Yeah, this is to check what the type for this vector is, like what the data, what the elements inside the vector is. No, for the class is only used for just some single things. And then list, we can make a list with different types of data. So we have, let's say, for the first thing we want to include in that list is employee ID. And we have 1, 2, 3, 4, and also employee names, and also number of employees. And we have those 3 lists, and they are with different length. And then we make it to a list, and let's check the list. So the first thing we have is the employee ID. The second thing we have are the names. The third thing we have is the number of employees. And we check it. This is a list. So this whole thing is a list. And then it's a little bit different from what we from a vector. So to get an element from the vector from the list, we need to use double bracket. So this is the second element of the list, which is the names. And the second element of the list is here. And data frame, we have, we also make some vectors first. So these first 3 rows, we make vectors. And then we use data.frame to make them to a single data frame. And now check the data frame. We have the column names. The first column is name, second column is language, and third column is age. And then we have the values of those columns. And say we want to get the element on the first row and the third column, which is first row and third column, which is 22. Let's check that. Yes, that's 22. So you use df bracket 1, comma 3. And then we want to get values for the variable age. We use this double bracket, and we have the values. And we can also use this $sign in between the data frame and the variable name. So we run this, we can also get the same result. And for a matrix, so let's say we want to make a matrix using number 1 through 9, and we want to make 3 rows, and so 3 by 3 matrix. And by default, matrices in R are in column-wise order. So if we want to make them by row, we need to set by row equals to true. So let's run this. And let's check A. So it's by row-wise order, then we have 1, 2, 3 by row. If we doesn't set and let the by row equals to false, which is the default, let's check B. And we have 1, 2, 3 in a column, order in a column way. And we can also check the dimension of A. So we expect it to be a 3 by 3, so check it, and it's 3 by 3. And we also have array. So remember, for array, it can be multidimensional. So let's say we have from 1 through 8, and we want to make it to 2 rectangular matrices, each with 2 rows and 2 columns. Then let's run this code. And run A. So now we have 2 rectangular matrices. So here's 1, and then here's 2, and each of them are 2 by 2. So for here, the dimension equals to C 2, 2, 2. So the first 2 is used for the number of rows, and the second 2 is for number of columns, and the third 2 is used for number of matrices. So let's try again with numbers from 1 through 12. So we can use this 1 through 12 to represent. So we don't need to type in 1, 2, 3, 4, 5, and all the way to 12. And then dimension we set to 2, 3, 2. So that's 2 rectangular matrices, each with 2 rows and 3 columns. Let's check that. So you can check there are 2 matrices and each are 2 by 3. Any questions? Okay, then now I have some quizzes for you. So for the first one, we have a vector. Do you know, you need to figure out some way to find the net length of this vector and unique values of x, and sort the values of x and frequency distribution of x. I will give you 1 minute. You can just search online, and I think there are many. Okay, let's check the solution. So for quiz 1, the first thing we want to find is the length. So we just use the length function. And let's run this code. So here is our vector. And then we use the length function. We can find there are 6 elements inside this vector. And then for the unique values of x, we use the unique function. And then we can see originally there are, unique. So originally there are 6 numbers here, but we have 2 7s. So the unique numbers are just 7, 9, 6, 5, 55, and 2. And we want to sort the vector in ascending order. So we just click, and this is sorted in ascending order. And we want to find the distribution, so we use date table. And then we can see we have 1 of 2, 1 of 6, and 2 of 7, 1 of 9, and 1 of 55. Then and this is a question about the array. So what's the difference of those 3 arrays? Anyone can answer? Okay, yes. Uh-huh. Oops, sorry, there's a typo, sorry. This should be 5, 1, 5, 5, 1, 1. Yeah, that's correct. Okay, I got it correct here. So we have 5 numbers, 1 through 5, and then so for 115 we have 5 matrices of 5 matrices with one by one matrices each, matrix each, and then for the second one, it's one matrix with one that is 1 by 5, and then the third one is one matrix that is 5 by 1. Okay, let's take a look at the third one. So this is just some calculation for matrices, and you can find those. There are some built-in functions you can find online. To save some time, I just show you the answer. So we have matrix A, we have 1, 2, 3, 4, and by order them by row. Sorry, and let me check A. So we have matrix A, we set by row equals to true, then we can order the elements by row. And for B, we use the default setting, then it's all the elements are ordered by column. And then we check dimensions, use the dim function. And then we can see the dimension of matrix A is 2 by 2. And the dimension for B is also 2 by 2. And we need to find the determinant, and we can use the built-in function dit, and then we can find the solution. And for sum of A and B, we can just directly use plus sign here. And then for A, the matrix A times B, it's a little bit different from just multiply 2 numbers. We need to use these percentage sign and then with a multiplication sign in between. And we need to find inverse of A and inverse of B. We use the built-in function of solve. Okay, let's continue. So the next topic is a function. So for a function, we have we use the function keyword to set up functions. So in this parenthesis, we can set up argument 1, argument 2. So some arguments you want to input, and for the function body, you can write your function and have some output. So we have these components inside a function. We have function name. So this is something you point to, like this one. And then we have arguments. So the argument is something you want to placed inside the function. And we have function body, which is the collection of statements that defines what the function does. And the return value is the value you want to output. So let's take a look at some function. So let's say, So let's say we want to set a function to print hello world. So for this function, we don't have any argument inside the parentheses. We just run the code. And when we run my function with parentheses, it just print out hello world. And then here, the next one, we set this function with 2 arguments, so first name and last name. And then we use paste to put first name and last name together. So this is our function body. And then we just run the code. Oops. And then if we run my function and we input 2 arguments here, so this Peter match the argument, the first argument, first name, and Griffin match the second argument, which is the last name. So if we run it, we can have the output as a whole string. So the third function we want to have is to set the set some default argument, and this we set the country to Norway, and then we also paste I am from and the argument. Oops. So if we run this code with nothing inside the parentheses, then we will get the default value, which is I am from Norway. But if we change the argument inside the parentheses, it will replace the default argument. And then it becomes I am from USA. And then we have some more, one more. So say we want to build a function with argument x, and we return 5 times x. So let's run the function. And if we put 5 inside the parentheses, then the expected value we will get is 5 times 5. Then that's 25. Let's check. Yes, that's correct. Any questions on this? Okay. Then here's another quiz for you. To write a function that takes x and y as input and returns the value y to x. Okay, let's take a look at the solution. So for this, we take x and y as input, and then we just return y to x. And for example, we want to make 4 to 5th power, then we have this. So that's 4 to 5. And we also have for loop and while loop. So the difference between for loop and while loop is for loop will always iterate through the entire sequence. And the while loop will stop the iteration when some condition is satisfied. So, for example, so for loop, it will iterate every single number. So if we have for I in 1 through 5, so it will loop through from 1 to 5, and then it will print 1 through 5. And for while, the first value we set it equals to 1, then as long as I less than or equal to 5, it will print I. And we want to loop through the next number, then we set I equals to I plus 1. And it also loop through 1 through 5. Because when we have I equals to 6, it's greater than, when we have I equals to 6, it's greater than 5, so it stopped the loop. Then we also have conditions. So if condition, if else, if else, if else. So if condition, so I would just let me double check. I will just skip this, and then if for more details you can check. And next, I would like to introduce you to some like real some sports data from some R packages. So if we want to use some data from packages, we need to install the package and also use library to load the package. And then, so for example, we want to use the Lemon data, load the Lemon package. We need to first install it and then use library to load it. Then we want to use the batting data from the Lemon package. Then we will do data, put the name of the package here, and then package equals to the package we want to use. So let's try that. So first, let's install and load our packages. So we install the Lemon package, and then we have the library. We load the package. Then we want to use the data batting, then we just load it from the package. And then we can check the data. So here's some overview of the data. And then we can do data manipulation use base R. So for string, string batting, we can check variables. Oops. So we can check different variables and their types. And then for names, we can just get the names of the variables. And for head batting, it displays the first few rows of the data set. So it displays the first 6 rows. And then for betting, for this, it displays the first 4 columns. So this is comma from 1 to 4. And then for the next one, it displays the first 4 rows. So previously is first 4 columns, and the next one is 4 rows, first 4 rows. And then for this one, it only displays the player ID. And the same thing for this. And then this displays the first 10 elements of the variable player ID and year ID. So you can see here there are 10 elements displayed for those 2 variables. And then for the last one, we can also create some new variable by using the $sign and the new variable name. And this is the function for the calculation for the first for the new variable. And let's run it. And let's check that. So you can see for now, the very last column is the new variable we created. And then, so next, we use dplyr. So the dplyr is a data manipulation package that is easy to use. Again, we need to install it and load it. And so there are many options you can use for dplyr. So here is a link for a dplyr cheat sheet. And then, so for example, let's install dplyr and load it. And here is another data set we want to use to do data manipulation. So this is a data set called salaries. And then let's check the data. And it contains year ID, team ID, lich ID, player ID, and their salary. So let's say we want to remove information from the data set. Then we can use this sign. This can only be used when you load the package dplyr. And let's run the code and then check the data again. So to compare, you can see this column is removed when we select those 4 columns we want. And for betting, we want to join betting for this. We want to create a new data frame with that joint betting and salaries. So, and we want to join them by player ID, year ID, and team ID. So we use left join, and we check our new data set. So now you can see we have our original betting data set, and we also have our salary in the very last column. And then we want to arrange the betting data set with player ID and year ID. So we rearrange the order in ascending order. So we can check if we arrange them in player ID and year ID, it starts from the they arrange the data in ascending order. So it starts from A and then in some ascending order. So then we also have visualization. We can do visualization using base R and also use the package ggplot2. So let's say we want to make scatter plot of doubles versus home runs. Then we first say we just want to make the plot for 2005, for the year of 2005. Then we first use dplyr to make a new data file, new data set, and we run the code. And for now, this data set only contains the data for 2005. And then we just use the plot function, and here's the x variable, here's the y variable, and this changes the x label and y label, and for the mean, it adds the title. And if we run the data, we can find the plot in the right bottom corner. And we can also use ggplot2. So ggplot2 is just one of the packages that's used to make visualizations. And here is also some cheat sheet you can check. And there are many plots can be made by ggplot2. And let's say if we want to make the same thing, which is home run versus doubles. And we first install and load the package. And then we run the code. So this time you put the data file you want to use here, and then use AES function to add x variable and y variable. And then we have and we use plus sign to choose the plot type. So geopoint means we want to make scatter plot. And now we have this plot here. So we can see they look different, but they plot the same information. And then we can also add labels, since for now this plot has no title and we want to change the X and Y labels. So we use plus sign again and plus labs and to add the labels. So now we can compare with the previous one. So this has no labels, and for this one, we have a title and we change the X, Y label names. So for the last one, let's say we want to group the scatter plots by ledge name, ledge ID. There are two ledges. So we just add color option inside the AES. Then we can get this plot. Okay, any questions? Okay, so for inside there are some useful reference you can use to learn more about R. And thank you for attending this workshop. Also, there are some parts I skipped in this slides. You can also take a look.